Hello there, it's Alana Tuckey, and I've received a question here about 7.2, number 35 from the study plan. So let's see what we've got here. We're going to assume the random variable x is normally distributed with the mean mu equals 50 and a standard deviation sigma equals 7. Oops, I'm going to do the example though, so it'll be a little bit different here. Assume the random variable x is normally distributed with the mean 50 and a standard deviation sigma equals 7. Find the 64th percentile. Okay, so let me remind you from chapter 3 what the heck a percentile is. So when you have a percentile, that means the percentage that is below your value is equal to whatever that is. So in this case, the 64th percentile. So let me show you a picture of what that would look like. There it is. And I need the normal. Okay, so I want it to be less than or equal to this to be 0.64. There we go. Okay, so this red area over here is equal to 64%. And this white area over here would be the complement, because remember the entire normal curve makes 100% or 1. So if you have 64% over here, then you'd have 36% over on the right. Okay, now what you're looking for is you're looking for the x score, the x value, right, that comes down the middle. Now keep in mind the mean for this one is 50 and the standard deviation was 7. So if I press compute and oops, it's going to have me, I'm going to have to do 0.64 in there again. There we go. So there's the mean of 50. Standard deviation's worth 7. The probability that x is less than or equal to this value, which is right here where that red line falls. See how this is 50, so this is 52.5. Right there is where that line falls. This horizontal line is your number line. Okay, so if that's the number line right there, then 52.5 is where that's falling for that vertical line right there. And then the area to the left of that is 0.64. Now you can see how easy this was to do in StatCrunch. I mean, it's pathetically easy. So let me just show you again what I did. I put the mean here, put the standard deviation here, and because I wanted 0.64, I typed 0.64 to be my area, and I press compute, and it will find the x value for me. Okay, so there's one way to do it. Oops, let me make a picture of that. Hold on one second. There we go, I copied and pasted it in. So this is the StatCrunch way, and we already did that one. Then let's say you don't have StatCrunch or you're not using StatCrunch or whatever. Okay, so you could do it another way. Let's do Excel next. So to do it in Excel, you just kind of have to envision the picture that you just saw. So what you need is you need norm.inverse, INV, and then it wants the probability. Now remember, this always wants a left tail probability. So in your case, that's perfect because that's what you've got, 0.64. That is the area in the left tail, right? So from the tail on up, all the way onto the left side of this vertical line, that makes 0.64. Okay, so I've got 0.64, beautiful, comma, the mean. Actually, you know what? Let me do this a different way. Hold on. Oh, it's going to get possessed with me. Hold on. Let me organize this just a little bit. So we want the left tail area. That was 0.64. It's whatever your percentile is, because percentile, if you'll remember from section 3.4, is always the percentage below you. So the mean mu was 50, sigma was 7, standard deviation. Okay, so the x value is equal to, I'm going to type it up first. It's norm.inv, and it's going to be 0.64, comma 50, comma 7. Or if you will, what I'm going to do is actually cell referencing it. Norm.inv. If I use cell references, then I can just type in different values and it'll automatically figure everything out for me. So I'll use cell B1 for the left tail, cell B2 for the mean, cell B3 for the sigma, i.e. the standard deviation, and there you have it. All right. So I'll copy and paste this in. So that would be the Excel way to do it. Okay, now what about a calculator? Well, the calculator has inverse norm underneath the distribution menu, which is above the variables button. So you hit second and then hit the variables button. And you can see inverse norm right here. It's number 3. Now, what was the area? Well, just like with with Excel, it's 0.64, the mean was 50, and the sigma was 7. So I'm pressing that number in 7, enter. Press paste, enter, and there it is, 52.5. So there's that one. Okay, then let me paste that in. So that would be the TI-84. So that's another way to do it. Oops, I didn't copy that. Hold on one second. There it is. Okay, so now that's pretty much it. I suppose I could show you one more way. There is actually a way to sort of finagle it by hand, but you'd have to use the table. Let me pull it up. There it is. Okay, so we'd go to the normal table, standard normal table right here. And now remember the area on the left, it's 0.64, right? That's correct. So you would go here and get as close to 0.64 as you can. So it looks like it's, see, this one's 0.32 away, and this one's, okay, so it's this one right here. So this 0.6406, that's as close as you're going to get. So what's the z-score for that? That is 0.36, right? Here's the hundredths place up at the top. Here's the tenths place over on the left, right? So the z-score would be 0.36. Let me do this by hand here. Not that anybody would really want to, but you know, in case you're stuck. So from the normal distribution table, the z is equal to 0.36-ish, right? Obviously, this is not going to be as accurate. Now, remember the formula for z-score, also learned in section 3.4. Section 3.4 is creeping up all over the place. So first it creeps up in the definition of percentile, and now it's creeping up here. So it's x minus mu over sigma. Okay, so if that's the case, we figured out this was about 0.36 is equal to, well, the x value we don't know. We know the mean is 50. We know the standard deviation is 7. Now, if you remember from algebra class, if you want to solve something like this, what you want to do is get rid of the 7. So let me bring this down here. So you're going to multiply both sides by 7. So you're going to do it over here on the right, and you're going to do it over here on the left. Oops, I just had my left and right screwed up. Yes, it's been a long day. Okay, so these are going to go away right here, and you're going to have whatever the heck 7 times 0.36 is here. 7 times, oops, not time, divided times 0.36, 2.52. There we go. So you say 2.52 is equal to x minus 50. Add 50 to both sides. Oops, I don't know how that happened, but that's okay. And there we go. It'd be x is, and of course this is really rounded because we didn't really have an accurate number from the table anyway, but it'd be 52.5 if you were going to do this with the by hand method. That's obviously a little bit off because this has a lot more decimal places of accuracy, but it's not bad. It did pretty well. All right, so there's how to do it 4 different ways. I hope that helps.